Yeah, so in this video, I'll explain the concept of plastic hinges. So this is a beam column joint. Now, in this beam, I've made this half symmetry. This is half of the I section. If you want to visualize the complete section, this is how it looks like. I have made it half because of the symmetry. And now, here, the beam will be pulled upward and again it will be pulled downward. This is called cyclic loading pattern. This is how back and forth movement will be given. Now, what happens in the plastic hinges, as I'm going to push it up, the this section will experience the maximum stress and plastic hinge will form over here. We'll see how it is forming. Let us first go through the component. This is my bolt. This is the bolt. Then this is end plate, and this is my I section web. Sorry, this is I section flange, and this is my web. And these are the stiffeners. So this is different mechanism. Now there is a purpose for why it has been. See, in this section we have reduced some area, so we want our plastic hinge to form over here. So I'll directly go to the visualization. Now this is how it looks like, the complete section, complete I section. These are applied just to stiffen this portion. Now I'm applying load over here for back and forth movement, and you would observe that slowly from top fiber to bottom to the towards the central fiber, the materials are yielding and slowly plastic hinge will form. Now what do I mean by top fiber? So this portion, now see, these are my top fibers. Initially these will be my top fiber. Slowly, if you see this block by block, if you consider this as first fiber, this is second fiber, this is third, this is fourth, this is fifth. So one over another, the fibers are laid, and finally we are getting the complete beam. So this is called meshing. Forget about it. I'll just directly go to the result. Now this, okay. First we'll go for the animation, how the load is getting applied. Then we'll proceed with the. Now just have a look. I have magnified it 10 times for your proper visualization, how the load is getting applied. So see, up, down, then again. So likewise, cyclic load is applied back and forth movement has been given. So if you would see that for each cycle, the displacement is increasing. See, it has put much lower. So it is a 17-second simulation. So see, this is the first cycle. You would see for first cycle, I have just pulled it up to this position. And if you want to visualize the result, I'll just go to. So for first cycle, I've applied a displacement of around 12 mm. 12 mm displacement, it is e to the power 0.01. So first cycle, it is 12 mm displacement. More than 12, which is around 13.8. Then on the bottom side also, it is 13.8. So on the upward, I have applied 13.8, then again taken it to the center, and you see, this was the initial position. This was the initial position of the beam. I have upward, I have applied 13.8, then again at the center, and downward 13.8. Then for the second case, for the second step, say I have increased the displacement, that is 18 mm, and then again 18 mm. So two cycles of same amplitude, and now again I'll increase the displacement. You see now this is 22 mm. It is 27 mm. Yeah. Now the displacement is 27 mm. So two cycles of 27 mm. Two cycles of 27 mm. Okay, two cycle is completed. Now I'll increase. You'll see there is an increment of displacement. It goes to 37 mm. So two cycles of 37 mm I will give. One cycle to two cycle. So two cycle is completed. So likewise, I've applied a cyclic displacement. I'll explain the concept, but before that, I'm just giving you the overview. So this is how cyclic loading is applied. Because if there is an earthquake, this is how some of these type of behavior will be observed during an earthquake for a beam column junction. So this is complete steel beam column junction. I'll just go for that different. Now I am going to show you a little bit closer. First have a look, then we'll proceed with the explanation. Let us have a close view. So once the plastic hinge has been formed, then you see, like in the last class I have explained you that after formation of plastic hinges, you'll observe that deformation is increasing rapidly. So let us now proceed with the explanation. I'm going to switch off the mirror option. Yeah. Now, as I have said, that plastic hinges will form when the material reach its yield point or cross its elastic limit. So if the material reaches its yield stress, that portion will become red over here. So you would observe that the top fiber is becoming red initially, top and bottom fiber, and slowly it will start progressing towards the center. So somewhere here we will consider at the center, we will consider neutral axis, and with the increase in deformation, as I have shown you that after two cycle I am increasing the deformation, increasing the displacement that I have applied. So with increase in displacement, you would see that the plastic hinges, the material is yielding slowly. All the material near the neutral axis is yielded. So it will start yielding from the top fiber, then slowly it will try to reach towards the center. If you remember in the last class, I have told you that once the plastic hinge formation has been achieved, then that means all the materials in this zone, all the materials in this zone have reached its yield point. So after that, you would observe that the displacements are increasing rapidly. So let us just play the animation. I would slow it a little bit, the speed. I'll go from the beginning again. Now see, I'll go each by one. This is my first cycle. So see, as soon as I have given, I have reached the first cycle, the maximum displacement I have applied is 12 mm. So for 12 mm displacement, see the material at the top and bottom fiber has been yielded, and some of the material on inner core, inner side is also yielded. So if I reduce the displacement, yes, so you would see that the material in the extreme fiber, this is the extreme fiber means the distance from the neutral axis, the extreme distance from the neutral. If I consider the neutral axis somewhere here, so this would be my extreme fiber. This will be my extreme fiber. These blocks are these blocks have already been yielded. Now in this block only part of the material is yielded. See the green zone or blue zone. The blue zone has not been yielded. That means the yield stress has not been reached for the blue zone. Only the red zone have yielded. That means the material has reached its yield point, only the red zone. So here the first fiber, the second fiber, part of the second fiber and part of the third fiber. So if you see there is a decrease in, if you see here most of the fibers are affected, here lesser than the extreme fiber, and here much lesser than the your other two fiber. Now if I go on increasing the displacement, I'll see as soon as I have increased the displacement much more, as I have increased the displacement further, the other fibers are also getting affected. So यहाँ पे पहले इनिशियली फर्स्ट फाइबर जो था वो इफेक्टेड था. जैसे ही मैंने डिस्प्लेसमेंट बढ़ाया, मेरा नीचे के फाइबर्स भी स्लोली मटेरियल यील्ड होना स्टार्ट हो गया. नाउ this is the negative cycle. So now I'll increase the displacement further. ये नेगेटिव साइकिल का डिस्प्लेसमेंट है. सी यहाँ पे here the displacement has increased around 18 mm. So for 18 mm, see, your zone of yielding, slowly the material near to the neutral axis is getting affected. पहले इतना सा affected था, देखो पहले टॉप फाइबर affected था, slowly टॉप एंड बॉटम फाइबर affected था, slowly ये सब भी yield होना स्टार्ट हो गया. मतलब ये जो मटेरियल्स है, यहाँ पे जो मटेरियल्स है, ये एक एक ब्लॉक मटेरियल, एक एक ब्लॉक को जोड़ के पूरा मटेरियल बनाया गया. तो slowly the yielding is increasing towards the neutral axis. Okay, so here somewhere I have the neutral axis. Now अभी भी ये जो मटेरियल है ना, ये यील्ड नहीं हुआ है अभी भी. इसमें ये जो रेड पोर्शन है, ओनली दिस पोर्शन has yielded, reached its yield capacity. So my yield stress is 265 for this. Now see 365, not so 265, 365. So that 365 has been reached by this zone. Now, if I increase further, this is on the negative side. It will be same for this cycle. Now, in this cycle, I am going to increase the displacement further. Now, see, I have increased the displacement to 22 mm from 18 to 22. Now, see, as soon as I go, I'll increase further. See, the whole material across the neutral axis has yielded. Some of the portion is still remaining, and this is the formation of. Okay. Now see, there is a deformation of the material, because why? Because this portion has already reached its yield point. Now after yield point, as I have told you last class, that once plastic hinges are formed all over the zone, then there is no more strength left for the material. So after that, a small increase in displacement, a small increase in load, the material will undergo deformation rapidly. So that is the reason why we're observing that in this region, the material has failed completely, and the material is experiencing large deformation in this region. The whole region is affected. So plastic hinge has already been formed. Now to visualize it properly, I'll go with the graph. If you see this graph, this is called a hysteresis loop. Now, to explain you better, we'll try to find out what is the maximum strength of this section, after which the plastic hinges are forming. Going to link both of them. Okay. So this is the zone from where we have started loading the material. This is the position. This is the position. We have started loading the material. Once we have reached the peak, this is the peak for first cycle. So if you see multiple cycles are there, I have applied some 13 mm displacement over here. It is visible. This is the position of the peak. So that black dot, I'm going to increase its size for proper visualization. So this is the maximum displacement in the negative zone. Now again, I'm going up. Same cycle is repeated twice. Now in this cycle, I'm going to increase the displacement. Now see, previous cycle was somewhere here. I have increased the displacement. So X is my displacement axis, and Y is my force. Force is in Newton, like 0.04 e to the power 6 Newton. Now still the material is increasing. See, first we were reached here. Now in the second cycle, we have reached little upper. If you see this is my first cycle graph. So we are here in the second section because the material has not yielded. If I go back to the first cycle, so this is my first cycle. So only small part of the zone is yielding. So we have reached over here. Now, as the material still has the strength, so in the second cycle, this is my second cycle. This is my second cycle graph. Second cycle means once I have pulled it up, then pulled it down. This is my first cycle. Then is second time again I have pulled it up, then pulled it down. So this is my second cycle. So this is my first cycle. ये second cycle है. So पहले cycle में मैंने क्या किया? पहले उसको ऊपर खींचा, फिर नीचे लेके आया. तो देखो पहले ऊपर खींचा तो थोड़ा सा ही मटेरियल यील्ड हुआ है, थोड़ा सा ही मटेरियल यील्ड हुआ है. ये सब अभी भी स्ट्रेंथ ये सब में बचा हुआ है. ये सब अभी तक फेल नहीं हुआ है. फेल मतलब यील्ड. ये सब अभी तक यील्ड नहीं हुआ है, यील्ड स्ट्रेस को क्रॉस नहीं किया है या यील्ड स्ट्रेस पहुंचा नहीं है अभी तक. सिर्फ ये जो हाईलाइटेड रेड पोर्शन है ये सब भी यील्ड हुआ है. सो इसी वजह से ये सब भी हो रहा है, लेकिन मैं इस पे अभी एक्सप्लेन नहीं करूंगा. मैं बस ये जोन को ही एक्सप्लेन कर रहा हूँ. तो अभी भी ये सब में स्ट्रेंथ बचा है, इसीलिए जब नेक्स्ट साइकिल में मैं डिस्प्लेसमेंट बढ़ाऊंगा ना, तो और भी मटेरियल मुझे रिएक्शन देगा, क्योंकि मतलब मटेरियल बोलेगा कि मुझे और भी मेरे में कैपेसिटी है. वो कैसे पता चलेगा? जैसे ही मैं देखो नेक्स्ट साइकिल में ना, मैं इसको जूम आउट करता हूँ. तो नेक्स्ट साइकिल में मैं इसका डिस्प्लेसमेंट को बढ़ा रहा हूँ. देखो थोड़ा सा बढ़ा. पहले स्ट्रेंथ इतना था यहाँ पे, ये लोड का वैल्यू था यहाँ पे अराउंड, अगर मैं इसको और जूम करूँ, अराउंड 43 ई टू द पावर 3 मतलब 43 किलो न्यूटन था. अब दूसरा साइकिल में जब हम यहाँ पे पहुंचे, तो ये अभी अराउंड 44 किलो न्यूटन ले रहा है. अभी भी थोड़ा सा पार्ट बचा हुआ है जो अभी तक फेल नहीं हुआ है. तो देखोगे नेक्स्ट साइकिल में ना ये और थोड़ा सा यहाँ पे स्ट्रेंथ देगा. देखो अभी भी थोड़ा सा बचा हुआ है, ये पीछे गया, ये बैक साइड में भी, नीचे भी वो इतना ही स्ट्रेंथ दे रहा है. अब एक ही साइकिल में दो बार घूमेगा. अब देखो, अब जब मैं आगे बढ़ रहा हूँ ना, अब ये आगे बढ़ेगा तो इससे देखो ना, इससे थोड़ा सा ये ज्यादा है. क्योंकि क्योंकि ये जो साइकिल था इसमें मैक्सिमम मटेरियल फेल हो चुका है. फेल नहीं, यील्ड स्ट्रेस पे पहुंच चुका है. मैक्सिमम मटेरियल यील्ड स्ट्रेस पे पहुंच चुका है, थोड़ा सा ही बचा हुआ है जोन, यील्ड होना बचा है. इसीलिए यहाँ पे देखो, यहाँ पे अब देखो, ये जो जोन है ना यहाँ पे थोड़ा सा और बचा हुआ है, बहुत ही कम बचा हुआ है. तो ये कहीं भी हमारा न्यूट्रल एक्सिस है. somewhere here we are having our neutral axis. So as we cross this portion, जैसे ही देखो ये जो पॉइंट है ना, ये अभी भी थोड़ा सा इससे थोड़ा सा ये ज्यादा है, बहुत ही कम है. लेकिन जैसे यहाँ पे ये अराउंड 44 पॉइंट समथिंग है और ये अराउंड 44.5 है. सो दिस इज 44 पॉइंट, दिस पोर्शन इज 44.4 यू कैन एज्यूम, एंड दिस इज 44.5. सो ये माइनर सा स्ट्रेंथ देगा. अब जैसे ही मैं नेक्स्ट स्टेप में जाऊंगा ना, देखो ये कम जाएगा, यहाँ पे आएगा, ये जो ब्लैक डॉट है ये यहाँ पे आएगा. क्यों कम जाएगा? क्योंकि पूरा जोन ही यील्ड हो गया है. देखो ये देखो यहाँ पूरा जोन ही फेल हो गया, अब कुछ नहीं बचा इसमें. अब कुछ नहीं बचा है, ये पूरा ही जोन फेल हो गया अक्रॉस न्यूट्रल एक्सिस, ऊपर का नीचे. इसीलिए देखो थ्रू आउट इट इज फेलिंग. तो अगर ये इसको ऐसे देखोगे, बैक साइड से भी देखो, ये जो जोन है ये पूरा यील्ड हो चुका है. अगर मैं इसका स्ट्रेस को दिखाऊंगा तो ये देखो, ये पूरा जो जोन है ना, ये पूरा जोन है ना, ये 2 3, ये जो रेड रेड जोन है ये 365 जो हमारा यील्ड स्ट्रेस है उसको टच कर गया है. देखो इफ आई शो यू द कंप्लीट जोन, the red zone, complete red zone, the value is 365, 365 e to the power 2, 3.65 e to the power 2, the 365. So this complete red zone has reached its yield point. Complete red zone has reached its yield point. अब अगर इसको मैं यहाँ पे दिखाता हूँ कंप्लीट दिस जोन हैज रीच इट्स यील्ड पॉइंट। ये पूरा जो रेड है अक्रॉस हैज रीच्ड इट्स यील्ड पॉइंट। इसीलिए देखो ये जो यहाँ पे था ना, थोड़ा सा मटेरियल अभी भी बचा हुआ था, इसीलिए थोड़ा सा स्ट्रेंथ दिया। जैसे ही इसको क्रॉस करता है, मटेरियल पूरा यील्ड हो जाता है, होल मटेरियल अक्रॉस द सेक्शन has yielded, which is why the strength is reducing. So what would be my maximum capacity of this joint? That would be my around, this is the maximum capacity. I would tell it 44.535 kilonewton. That is my maximum capacity. After that, the whole zone is yielding. After that, it is reducing. So अगर मैं और थोड़ा सा इंटरमीडिएट वैल्यू लेता तो और मुझे अच्छे से रिजल्ट मिलते। जो ये मैं थोड़ा मिस कर रहा हूँ, ये जो जोन है ये मैं मिस कर रहा हूँ, लेकिन कोई नहीं। यहाँ पे देखो, ये जो है ना, इससे ये थोड़ा सा, यहाँ पे अगर मैं इसका वैल्यू देखता हूँ तो ये आता है 44.04, एंड इससे पहले का ये वाला आ जाएगा 44.3। सो आई कैन से दैट दिस इज द स्ट्रेंथ ऑफ माय जॉइंट, दिस इज द स्ट्रेंथ ऑफ माय जॉइंट। इतना ही ये जॉइंट ले पाएगा। This is the maximum capacity of force it is able to take, around 44 point something। उसके बाद का जो साइकिल्स होगा ना, इसके बाद का साइकिल्स में ये वाला है, उसके बाद का साइकिल में देखोगे और स्ट्रेंथ नहीं ले रहा है, बिकॉज द प्लास्टिक हिंज हैज फॉर्म्ड, होल मटेरियल अक्रॉस द सेक्शन हैज yielded। नाउ द सेक्शन इज नो मोर कैपेबल ऑफ टेकिंग एनी फर्दर लोड। सो इसके बाद देखोगे ये डिक्रीज हो जा रहा है। एंड मैंने बोला था आफ्टर फॉर्मेशन ऑफ प्लास्टिक hinges, लास्ट क्लास में मैंने बताया था दैट आफ्टर फॉर्मेशन ऑफ प्लास्टिक hinges द मटेरियल विल अंडरगो लार्ज डिफॉर्मेशन। तो ये सब में देखना आप डिफॉर्मेशन आएंगे, ये जो पार्ट है ना ये बहुत ही ज्यादा स्ट्रेच होंगे। अब मैं अगर इसको आगे जाता हूँ, फिर से बैकअप पोजीशन। अब देखो मैंने बताया था कि जैसे ये जो हम क्रॉस कर रहे हैं, क्योंकि हमारा पूरा और यील्ड हो चुका है, ये देखो डिफॉर्मेशन का स्टार्ट हो चुका है, स्ट्रेच होना। इसमें तो बहुत ही ज्यादा डिफॉर्मेशन आएंगे। देखो नॉट डिफॉर्मेशन, मटेरियल विल अंडरगो लार्ज एक्सटेंशन। सो ये जो साइकिल है ना, देखो इसमें हमारा डिस्प्लेसमेंट, मटेरियल स्ट्रेच होना स्टार्ट हो गया, मतलब प्लास्टिक इंच फॉर्म हो गया है। अब जरा सा भी लोड लगाओगे तो मटेरियल विल अंडरगो रैपिड, मटेरियल विल शो रैपिड डिफॉर्मेशन ओवर हियर। देखो स्ट्रेच होना स्टार्ट हो रहा है। उसके बाद और बढ़ाया मैंने डिस्प्लेसमेंट, और ज्यादा स्ट्रेच हो रहा है, इट इज इंक्रीजिंग। सो इट shows that plastic hinge already formed, and इसके बाद ये large deformation experience हो रहा है। So if you remember in the last class I have told you that after formation of plastic hinge the deformation will increase rapidly। This is how plastic hinges, plastic hinge concept works। So हम ये जो strength है ना, जिसमें हमारा मटेरियल बस सारे मटेरियल yield हुआ, and we will be considering that as plastic hinge, and that is my section capacity। after that उसके बाद के साइकिल्स देखो ये ऑटोमेटिक लोड कमते जा रहा है। so this is called cyclic curve, and that's all।